This assignment is going to be using that property that I was talking about in the last video that we ended up not using, but really, really important property. And it's usually, I don't really like these problems. They're too basic, I would say. So I'll try to get you guys a worksheet or something that makes this a little more complex, because these are the fun kind of problems that definitely will show up on the AP test that really requires you to understand or at least know all the properties. And they're pretty simple. I mean, we went over them before, but this property is my favorite. So what it is the integral from A to C. If we look at the right-hand side, the integral from A to C. So that's the total integral, which is the area under this curve from A to C. That area. So the area under the curve from A to C, this total area, if I were to shade in this region, we can break it into two pieces right here. Right in the middle, not directly in the middle, but somewhere in between exists B. So if we integrate from A to B, that's the area from A to B here. That's going to give us this area here. So that's what this represents. And then if we integrate, so starting from B and go to C, if we integrate, that would give us the area here, this shaded region. And if you add those, notice the plus sign, if we add those two areas together, it's the total area from A to C, so it's that total integral. So it's just saying we can divide up the two. Very, very simple property, but for some reason people just over-confuse it and make it more difficult than it should be. That's all it is. It should make complete geometric sense. Sometimes it helps, though, if you do get a little mixed up. I notice sometimes it helps if you just draw a number line and put like A and C, or, because some of these are going to be like from 0 to 10, and you'll see equals from 0 to 5 plus, 5 to 10. So you might have to put like 0 and 10 and realize 5 is in between and split up your two integrals. So it might help to draw a little number line to picture it. So I do recommend that if you do kind of struggle with this. That way you can kind of visualize this each time. You probably don't need to draw a full-on graph each time, but geometrically makes sense. You add the two areas, you get the total area under the curve. So let's look at this one. The integral from 0 to 4. Now I'm looking at this 0 to 4. We don't know. We know 0 to 3 is 5. We know 3 to 6 is -6. But we don't know 0 to 4. So we can't just abruptly stop it at 0 to 4. So we kind of have an issue there. But we're adding it to the integral of 4 to 6. So we would say 4 is somewhere like right here. We're going to add it to this. Well, we could just find the total integral from 0 to 6 and call it done. That's what that's saying. We have 0 to 4. 4 to 6 is the same thing as 0 to 6. So if you find that area from 0 to 6, 5 minus 6 is -1. That would be that area. So pretty simple. And I think this whole assignment is pretty much like that. -8 to -2. -2 falls right here. So we can't just go -8 to -2. So we kind of have a problem with that. But look at the rest of it's going -2 to 0. It's just going to complete that full thing. So we can just go -8 to 0. That's basically the same. It's the same as the integral from -8 to 0 of f of x dx. Oops, I put -2. -8. And so from -8 to 0 would be 5 minus 6 again, would actually be -1 again. Okay, this one, evaluate the integral from 6 to 13. So we're probably going to have to divide this up into different integrals. So 6 is right here. And really, we're already dividing these shapes. See, that would be 9. Area would be 9. 2 by 3 would be area of 3. And then to 13, I'm going to do this in red because this is negative area. That's a 2 by 3, so that would be -3. So from 6 to 13, the area would be 9 plus 3 minus 3, which is 9. Last one from 3 to 6. So 3 is right here to 6. So if we're doing that, what you can see is this is a 1 by 2. So that's a -1 area. And then this is a 2 by 1, 2, 3, 4. 8 divided by 2 is 4. So that would be an area of -3. Or not -3, a +3. So just dividing up those areas. Like I said, this one makes it really basic for this property. I prefer other problems where they kind of give part of the integral, and I'll see if I can find a worksheet or something on that we can work on in class.